In this lesson I will be explaining what the polar form of a complex number is, and then I will be showing how to convert a complex number from Cartesian form to polar form. So firstly, let's recall what Cartesian form itself is. And Cartesian form is simply a method of expressing a complex number in terms of how far across it is on the x-axis. In this one here, it's a units across and it's b units up. So that complex number z is therefore simply equal to a plus ib. That's what we mean by Cartesian form, or rectangular form as it's sometimes called. Now, polar form on the other hand, if we just come down here and look at the same number, so here we're looking at the number z equals, it's the same number, z equals a plus ib again. There it is in Cartesian form. The difference this time is we're going to try and look at the number another way. Instead of how far across we are, which is a across and b up, we're going to think about that number as being a certain distance out from the origin, or it's on this circle here, and also what angle it is from the real, what angle it makes with the real axis. And when you express it, I've color coded here, when you express it in these red coordinates r and theta, it's then called polar form. But it's still important to realize it's the same complex number we're talking about. Now the next thing is, how do we convert from one form to the other? And this is how we do it. You think of the connection between the old world of Cartesian form and the new world of polar form, and what connects the two worlds is this green triangle here. And we can put our old coordinates on it, our old Cartesian coordinates, which are a across and b units up, and straight away you see we form a right angle triangle where a squared plus b squared is r squared. So straight away r squared by Pythagoras is a squared plus b squared. So r is the root of that, which you should recognize at this stage as the modulus of the complex number. So that's the connection between a, b and r. To bring theta into the equation, we have to spot that the tan of theta in that green triangle again is opposite over adjacent, which is b over a in our case, or saying it the other way around, theta is equal to inverse tan of b over a. And lastly, to tie it all together, we do some basic trigonometry. We look at theta here and we realize that the cos of theta is equal to adjacent over hypotenuse, which is a over r. So we can think of a as simply r cos theta. Do the same for sine. The sine of theta is equal to the sine of theta, just make sure that's not mistaken as a 0. Sine of theta is equal to opposite, which is b over adjacent r. So b is r sine theta. Again, try and get that theta written properly. And now we have a clear connection between the old world and the new world. A and b, which are the old Cartesian coordinates, are now in the new polar coordinates r and theta. So we can revisit our number, which was z equals a plus ib, and we can sub in for a and b now. Z is equal to r cos theta plus I times r sin theta. There's our substitution. A has been replaced by r cos theta, b has been replaced by r sin theta. Take out the common factor and r comes outside and you get cos theta plus I sin theta in the bracket. And finally, there we have it, the old Cartesian form, z equals a plus ib, and the new polar form, z equals r cos theta plus I sin theta, and not forgetting what r and theta are. R is the modulus of the complex number, and theta is the inverse tan of b over a. So that's how you convert from Cartesian to polar form. Now let's just do an example on that. So for example, convert z, which is 3 plus 4i, into polar form. So here's how we do it. We follow the steps I outlined earlier. Two important things to get here are the modulus and the angle. So the modulus of z, I should mention at this stage, if you just go back to the previous slide for 1 minute, that angle is sometimes called the argument of z as well. So back to our question. You can do a quick sketch of where the number is. So there's your z, so it's 3 plus 4i, so it's 3 along this axis and it's 4 along this axis. That's the imaginary axis there, and the real axis. And the two things we need to write in polar form are r and theta. And from the previous page, well, we know what r is. R is the square root of a squared plus b squared, which is in our case the root of 3 squared plus 4 squared, which is 5. And theta is equal to the inverse tan of b over a. So if we go back to our triangle for a sec, b, the distance there is 4 and the distance there is 3. So it's the inverse tan of 4 over 3. And now finally the number in polar form. If we revisit the previous page for 1 minute, z, any number a plus ib in Cartesian form can be rewritten in polar form as r cos theta plus I sin theta. And we have both r and theta now. R is 5 up here and theta is 53. So it's 5 into the cos of 53 plus I sin 53. Just make sure that's emphasized is that it's degrees working at the moment as opposed to radians. So that's it. That's how you get the polar form of a complex number.